Hello, good morning, everyone. So, welcome once again to online training course on disaster risk reduction and climate change adaptation for CARICOM and SICA member countries, day 4. So, Assalamualaikum warahmatullahi wabarakatuh. My name is Alvita, and I will be a moderator for today's session. The topics of this session will be early warning system and climate change information system. On the next 2 hours, we will have 2 parts of the session, and we will have 2 panelists on this session. And it will be Dr. Agi Wandala Putra from BMKG, and Dr. Ernat Armi Susandi from ITB and BIN. First, I will invite Dr. Agi Wandala Putra. Dr. Agi Wandala Putra will present the first presentation about operational system for early warning of extreme weather in Indonesia. Dr. Agi Wandala Putra, are you here yet?
Yeah.
Yes, yes.
My voice is quite clear, Mbak Alvita?
Yes. Hello.
Okay.
Dr. Agi Wandala Putra has been the weather early warning subcoordinator at Indonesia Meteorological, Climatological, and Geophysical Agency for the past 3 years. And he is also the Jakarta Tropical Cyclone Warning Center coordinator and the Southeastern Asia Oceania Flash Flood Guidance System focal point. He specialized in extreme weather forecasting. And Dr. Agi Wandala Putra holds a bachelor degree in mathematics, a master degree in mathematics also in computer science, and a doctorate in environmental science. He has over 10 scientific journal articles to his credit. So without any further ado, the place is yours, Dr. Agi. Go ahead.
Well, thank you very much, Bu Alvita. Assalamualaikum. Good morning, everyone. It's to be honored to meet all of you here with this really good opportunity. I believe that you just following a really long week, I think. And today we will talk about the weather phenomena and also how it's alerting and its system. So I hope that you can enjoy the sessions, and please just deliver your message if you have necessary questions to me, and I will have a look on chat probably, and also will answer at the end of the sessions. And maybe it's a bit different compared to the previous sessions. I would like to share more about the practical and also how actually we give the early warning informations, yeah, to our regions. And it will be good also to listen to your thoughts, yeah, about the system in your area. So it's my presentation is quite smooth, Bu Alvita.
Yes, you only need to yes,
yeah.
yes.
Thank
okay.
you. Okay, so I will start the presentations, but then also I would like to take time slowly to give you some example of it, and do not hesitate if you have again the question. So again, thank you for the introductions. My name is Agi. Right now, I still working as the forecaster and also manage the weather early warning in Indonesia. As you know, Indonesia is really a large countries, and also same also with the BMKG. It is the name of the agency for the meteorology, or you can call about the National Meteorological Agency. It's our agency is managing the early warning on the weather, climate, and also the earthquake or tsunami. But today we will talk about how we can actually make the operational on the early warning system in Indonesia. So before we start, it's really good to share with you that Indonesia is the mainly we have the tropical island or a continent system, maritime continent system, which is we have a really big number of the heavy rainfall. But it's quite interesting. When we come through month by month through the years, we have so many related activities with the hazard that came up from the weather phenomena, which is when we start talking from the December to February, we will have a look on the detail about the flood, landslide, high wave, flash flood storm, which is the wet period. But also the other side, before we moving to the dry period, we will also have a look on the transitions period on the March to May, and also the September to November. Through the nationwide, we can also have a look on the small tornadoes, thunderstorm, hail, and of course on the June, August, we since Indonesia we also have a so big area for the forest. We really concerned also about the drought, forest fire itself, and also the high wave. So basically, these conditions make weather agency Indonesia is come into the critical situations, because we need to take seriously day by day, month by month, because the fluctuations or the change from switching from the wet situations to the dry situation is going to be really interesting to see the high impact weather with so many casualty and loss of fatality. So that's why we need to be ready and use the high technology and the better observations to make our service better. So I hope that these sessions, I also will bring some use case, so you can understand clearly what is actually the transformations that currently used around the world. Because follow up the international body from the National Meteorological Agency, it's called the World Meteorological Organizations, that the weather services is need to be moved from the basic or the conventional concept into the new concept. Before, we will always talking about what the weather will be. So the technology, the services on the weather, on the meteorology, normally used to based on the threshold of the meteorological basis, like the 50 millimeters or like 35 knots winds. We talk about the heavy rainfall, something like that. But then we realize in terms of the disaster risk reductions that this information is no longer enough, no longer sufficient anymore. So we need to move into the new paradigm from what the weather will be into what the weather will do. So as the meteorological agency, we develop and exercise so many technology and also some solutions. Finally, we need to inform the public into the impact warning content. So this is designed not just only decided by meteorological agency, but it's developed slowly from the user needs that comes up from the public and also from the stakeholder. And then we start to have the impact-based forecast and also the risk-based warning. I believe that this methodology is in the coming future, it will be the main paradigms that we'll use around the world, because some countries like UK, US is starting also to use the paradigm of the impact of forecasting. So it's going to be interesting because we're talking about the early warnings, but it's good to you to know that we also touch into the impact area, but we never left the weather itself, the threshold, the standards. So we need to have a more capacity on it. So if you have a look on the main concept of the warning itself, before we can do the quantifying and also the reducing impact from the threat of the weather or hydrometeorological hazard. So we need to have a look on our countries, on our area, what kind of responsibility that available inside the country. So I believe in the previous day, you hear about the National Disaster Management Agency capacity, that they have a role to measure the exposure and also to check the vulnerability in each area, because this information will be really important to quantifying the social and also the economical impact. But then in Indonesia, or in the National Meteorological Agency, in BMKG, in my agency, we're working on the weather and also the geophysics area. So the weather and climate extreme standard analysis, we merge together with the information that comes up from the disaster manager, and then together we can quantifying the potential of the impact. So in the future, we also open as wide as we can to have also much input from the voluntary basis, public, stakeholder, academia, and also many national governmental organizations, non-governmental organizations. In the coming future, again, that we also need the conceptual about the multi-hazard early warning system. But in this slide, I just want to underline that you also need to clearly understand the basic area when we have or we expect to have a really good warnings, and it's well delivered to the public. Before on the downstream area, we need to see that on the blue box here, we need to identify the hazard information. So this is the role of the meteorological agency in the conventional basis, because we will do the observations with a good observations. So we can use the observations for the modeling purpose to detect as early as we can the hazard that will come. And then we also will use for the monitoring, make the analysis, and don't forget that we need to also develop the forecasting technology. And on the spatial basis, we need to have also the capability to map the area so we can identify the area of the accurate warning, so the people can reach the safety, and also they can respond as fast as they can. So before we going through the warning itself, we need to have a look on the detail for the multi-risk analysis. So this is the area that right now meteorological agency is no longer just doing the regular business anymore. Not just only on the observations only, but we also need to move how we can analyze all the informations containing the exposure, the vulnerability data, and I hope that in your country you have all this kind of data, merged with the technology like the probabilistic forecast, the ensemble forecast from the numerical weather predictions. So then we can deliver really good warning with the probability of affecting information for the people and also for the assets, and the other informations like the possible impact, and we can classify so many sector, so many cluster of the different stakeholder. And the important things on the terms of early warning itself, we also need to identify the general public on each sector, because the early warnings means also for the early actions. So this is the campaigns that happening worldwide. So we need to prepare and respond as fast as we can, but in the good decision, so we can save the people. So I hope you get the main idea before we going through the technical aspect, or from our lesson learned in Indonesia, how we can develop a good weather warnings. So if you come into the clustering of the multi-hazard early warning system, so many activities that we need to consider. We need to start with the Earth data observations. With the really good observations, you need to identify in your area what kind of the tools, like the weather radar, radio sound for the upper air observations, satellite observations, AWS, automatic weather stations, and many observations capacity. And also we need to talk the area of the data and also the information collections. We need to see the capacity of the networking, the computations capability, the productions capability. So we can use all this information for the hazard detections purpose. So we need this information system containing the hardware, operating system. So we will start to have one profile. It's called the data analysis or the data engineers. because they will help the forecaster or the meteorologist to make the hazard assessment before they can quantifying the impact-based forecast and the warning. So this is the step-by-step that we need to do on the really basic part until the providing the advisories or the warnings. But the other side, we also need to develop in terms of the how we can deliver really good risk communications. So the way we can disseminate our informations, like in Indonesia, of course, we use the high technology for the weather disseminations, like the social media, WhatsApp or Telegram or many others canal, like also the website basis portal. But also we not forget with the conventional basis one, like the sirens, the television, and then radio. And also, if you have a look really with the traditional way, we can also with the use the stick wood for disseminate the information. So anyway, in terms of the how we expect to deliver a really good response for the early warning. So we also consider the conventional basis of the methodology from the basic observations until the disseminations, because this area need to be balanced, yeah, with the good informations. But if that's not delivered, so it's going to be really difficult to save the people. Okay, so now it's time for sharing with all of you all the basic informations that we have. So you can also see directly in your computers, probably. So the first early warning scenario or technology that I would like to share with you is the impact forecast. So if you can see the right side. So right now in Indonesia, we not just only deliver the weather warning only for heavy rainfall, but now we need to also to put impact informations, the possible impact informations, and who need to be respond, what they need to do, and also the risk level. So we need to understand that right now we have the three main level, yellow, orange, until red one. So we divide the direct stakeholder that they can respond directly, like disaster manager, police, army, something like that. But also we consider also to give the informations for the general public. So this information is developed together with the meteorological agency and also the disaster managers. So if you not mind, I want to share a bit about this kind of informations. So let me share. So you can come to the website. It's called wait a minute. The signature. Oops, apologize. Okay. Okay, so I will share with you, for example, one of our system. It's called the signature.bmkz.go.id. So I would like to use this tool for all of you to see the possible delivery service for the warning, because these informations will be really useful if you can give the information to the public. For example, we have so many alerting area right now. So we can see the polygon here, the yellow warning in Indonesia. Maybe I will change a bit information. So we can have a look here. So you can right now try to see the basic warnings that is available here, just switch into the English versions. And you also can see the level. So this information is useful to communicate to the people, so they can start to deliver to their own the regional authorities to see how actually the weather will give impact to their area. So if you have a look all the areas, so we consider to manage all province. Yeah, I will switch to another type of map. So all the nations need also to see directly day by day. But later on, I want to also share with you with the technology of the weather radar, satellite. We can also see how the information is going and can get the early actions that we expect to reduce the impact of the weather. So again, you can have a look on the signature.bmkg.go.id while I will back to the main presentations first. So all those information is not come automatically, but we also deploy so many forecaster. So for that purpose, of course, we need to understand how we work on the weather warning system in Indonesia. So this is the main design, how we can deliver the extreme weather warning for the public. So the first area on the left side, that we need to consider the tools or the capacity of the observation system. So glad that in Indonesia we have quite a large observations network, but maybe I'm not really going into the deeply of the networking. Like the weather radar, now we cover 42 weather radar all around Indonesia with additional or some typical of the band, like X band, C band. And then also we have the satellite geostationary to see the 10 minutes cloudiness movement. And of course, we cannot also forget about the manual observations, the conventional one. It's synoptic basis observations, automatic weather stations, rain gauge, and many other. So we use all this system into the analysis and the forecasting system. But before doing that, later on, I will explain to you how actually the modern system that we already implement since 7 years ago. But the idea, before it comes into the general public, the specific stakeholder, we need to have the forecaster or the people who monitor the weather situations in the nowcasting approach. In every province, we have the 34 province before we add additional one. But in every province, we have some office, but we dedicate one big office to respond or to cover all the early warning in each province. So we will have the representative in each area. So for producing the weather forecast itself, we have so many cluster of the data. We use the numerical weather predictions. It's containing so many typical the numerical model. And of course, we need the observations data and also the atmospheric analysis. Apologies, is still in Indonesia, but anyway, this kind of number with the 42 weather radar, 113 of the meteorological stations, that's been the complete one. The upper stations and then marine meteorological stations and more than thousands of automatic weather stations. And we use also some numerical weather predictions that came from global providing numerical weather predictions like ECMWF, GFS from NOAA, Unified Model from UK, ARPAGE from Meteo France, and many others. But also we develop our own downscaling modeling because we need to adjust into our weather conditions with the assimilations process and some additional post-processing area. So with this all equipment, it assists the forecaster to get the best data from the good quality control of the system. And right now we also prepare the supercomputer to proceed the biggest computation for our own regional models. So basically, from this or all this equipment, just keep the number of here. But I need to introduce you the concept of the national digital forecasting that we implement in Indonesia, because we use the high technology for the computations that integrate all the equipment into the smart solutions and also smart switching system. So every province can share their warning aspect and also deliver into really good telecommunication system. Okay, so I really like to explain to you also a bit about the integrated weather modelings, if you also work in this area. So basically, we use so many resources around the world because the one of the solutions that can help the forecaster to predict the extreme weather, of course, is the numerical weather predictions. As I mentioned earlier, we use the global model into the downscaling area on the right side. And we recently also start to develop our own model. We collaborate also with so many universities, including the ITB. And we expect that in the future, we can use a better, or maybe reducing the false alarm, a better accuracy, and also we can use the probabilistic information for the weather forecasting itself. And again, this is the example of the coverage of the weather radar. So all this informations, we believe that maybe it's not covered yet, all the land area, but anyway, the purpose of the nowcasting information is can really useful and can deliver very well into the public. So this is the area of what we call as the nowcasting. So again, before I move to the last part, again I would like to share also again with you some of example. So right now, in Indonesia, since we deliver the responsibility area or chart for the producing of the weather alert, so you can see from this pages that right now we have the real-time warning that's still running right now. So actually it's different from the impact forecast that I already told you earlier. Right now we can see the area that occurred with the heavy rainfall. So this is an Indonesia area. We can see on the detail some area with the yellow warnings and also the orange warning. But in this terminology, we can see that some area will get the rainfall in the real time. So you can see on the right side, the durations, yeah, specific into the time basis. So I will give you some example, like in my area, I stay in the capital. So in the southern part of Jakarta, from right now it's 9 p.m. until midnight, we will occur the heavy rainfall in the southern area of Jakarta. So this information is really useful. Then we also make the automatic informations to the public. So we design really simple the graphical informations and it's delivered to the people, but also it's connected into the mobile apps, something like that. It's called the Info BMKG. So it's Info BMKG application. So we can see the area of this is the city. So right now the western area predicted there is some rainfall on this area. In the other side, we also provide the detailed district that will occur with the rainfall. So again, previously I tell you about the impact informations, that possibility to see how big the risk on day 1 into the day 3. But now I give you an example for the approach of the nowcasting area. To prove this information, I also can show you some the radar observations for the alerting that now happening in West Jakarta. So you can see this area now is start the rain, yeah, so in some area. So it's a really simple methodology, but it's used so many technology, not just on only weather modeling, numerical weather predictions, but also we use the satellite basis and weather radar. So that's the second aspect that I deliver to you from my presentations. So I will move into last part of my presentations. Again, we are responsible for the alert for the weather, extreme weather like the heavy rainfall. But in the other side, actually, on the concept of the multi-hazard early warning system, it's not just only the extreme weather, but we discuss about the flooding, drought, forest fire, coastal inundations, and also we need to integrate with so many stakeholders and include the connections with another warning authorities. So we use solution is called the Camelot Protocol. If this is new for you, so this is new technology for the communicate the early warning, so it's easy to integrate it. So I bit back on the basic of the warning productions. So this is the main concept that may interest you to implement in your countries. Basically, from the observations platform, before we use the small methodology to design the weather informations, but now we also extract the capacity with the data collection system, and don't forget about automatic message switching system. So this is the switching system that can manage all the big data and also the so many type of the weather format, the weather observations data format. And also do not forget the main one, the smart one. It's called we call it the central information and processing system, but anyway, it's high performing computers, or soon it's going to be supercomputers, and we can collaborate with the climate data management system. So all those informations will generate it in the daily basis, in the hourly basis, into the forecasting system. And finally, all the forecaster in Indonesia can see the same data, same information, so they can make the right decisions for their area. So back to the last part that I also introduce you about the forest fire preventions. We have so many area for fire mitigations, forest fire mitigations. We can use the seasonal forecast, climate outlook, drought monitoring, geospot mean the satellite geostationary for the hotspot. And we also have the fire danger rating system, or FDRS, the technology for forest fire detections. And we use the monitoring the air quality in the daily basis and also the global atmospheric watch. But anyway, this technology, it's called the forest fire danger rating system, or FDRS. Actually, it's the basis from the Canada, the algorithm. But if you interest that this solution is developed from some parameter of the meteorology, like temperature, humidity, wind, also the rainfall, then we start to also implement on the it's called the area is ASEAN, yeah, the Southeastern Asia area, but also we cover a bit of Oceania. It's called the Spartan. Spartan is the Indonesian terminology for the FDRS. I will show you later. But anyway, these informations will include all the informations for the dry things. Yeah. So before we talking about the wet area, but now on the last presentations we talk also for the forest, for the dry area, also including the forest fire threat. So inside we can see and also measure the intensity of fire and many algorithm. So we can use easily to prevent the weather situations in Indonesia, because we also have an issue about this when we start to enter the dry season period, like in the coming months. But the index itself actually is containing so many different informations. Okay, before we see some sample of the warning itself, I also want to introduce you the Camelot Protocol. So this is the way that we can share the informations, not just only for the Indonesia regions, the different stakeholder, but also for the other the entities, yeah, or maybe the other countries. So all the world can connect directly and can take the fast response, so people can save and take their response as fast as they can. So this is the example. So the last area, I also want to give you that all those informations, the warning, it cannot be successful without the public outreach programs. So we have so many programs like the climate field school, weather field school. We also make the tabletop exercise for the flooding, for example. And also we can design together with disaster manager with the tactical floor game to simulate how we can respond when the hazards coming, like flash flood or flooding. And the other side also, this information is really good to invite as much as we can the networking of the voluntary basis. So that's what we did in Indonesia. So that's why from the experience of the big cyclone last year in the April 2021. So this is the weather observations that occur in the East Nusa Tenggara, one of our province in Indonesia. The impact is quite large there. So many people died, but then some people saved because those public outreach programs can really help people directly, so they can respond on the good time and also can save the community. So this is the example. One of the leader in this area of fishermen is called Mr. Dewa. So they convinced the villagers to evacuate before the Saroja cyclone is coming, because he already learned the basic or the standard informations for how we can respond from the hazard hydrometeorology with a really simple way with the WhatsApp group information. So that's how important we can deliver, yeah, the good warnings, but also we need to strengthen the capacity and also the capability from the public, so they can take their responsibility and save their family. So before we going into the questions, I would like also back to some example that may you can explore later on, and perhaps you can develop in your own countries. Okay, so I will give you some example for the forest fire mitigations. So you can go through this website. It's spartan.bmkg.go.id. You can see on the left side. So you just start it inside. So the mitigations of the weather early warnings, again, not just only for the wet things, but also the dry area. So this kind of the informations for the forest fire. So you can see the observations and also the forecasting data, yeah, for the forest fire mitigations. So I will give you some example. For example, in some of province in Indonesia, if we just give them the access, for example, like this one, they can see the forecast and also the history in the coming in the recent area, so they can see the threshold basis. Yeah, it is glad that even now it's actually on the dry seasons, but since we have the La Nina, so the area of the level, yeah, so there is no red area on this area. But also you can just see, yeah, the other area that with the different threshold, how actually the information will be impact for them. So this is the example for the forest fire mitigations. But I will give you some additional informations. So for the forest fire mitigations, we did so many activities like the weather modifications, and then some direct field work. So they can also see the radar information here inside. So this is really useful for the mitigations aspect. And also we can check the quantitative precipitation estimations. And of course, with the other data like the satellite, the hotspot itself, we can check the day by day how big the area of the warning, so you can see the hotspot area, right? So this is really useful for starting the mitigations with all those equipment like the satellite data and also the modeling. So this is another example again. In Indonesia, when we come into the first slide I show you, the dry seasons, the wet seasons, the rainy seasons, I mean, we can use some different approach, yeah, and different technology, which is also maybe can really useful in your countries. So on the specific area, we can take a really good decisions to prevent the or to save the people from the hydrometeorological hazard. Okay, so then before I come into the questions, I will also give you some word connections, yeah, for the weather alerting. So actually now all the word is already connected for the weather alerting. So I just give you, wait a minute. Okay, this is the portal that provided by the WMO. I think you came from this area. So anyway, if you already connect to the word, so you can see what is actually the right alerting. Yeah. So we use, it's called the Camelot Protocol. You can see here. We can see the active warning that's available right now. So Indonesia is already connected, but also you can see in other countries. So I believe now there is Mulan, yeah, tropical cyclone, now reaching the area of China. So all this information will be quite connected through around the world. So if you can learn how we can see the basic connections of the warning, so it can be really useful for sharing, yeah, from one country to the other countries, because you can understand that the weather hazard is not really know about the boundary area like this one, yeah. So it's going to be interesting. I hope you get some critical point that I deliver to you, the impact forecast, and then the no-casting approach, the forest fire rating system, and also the last one is how we can connect to each other with the warning platform, also the public outreach and public learning program, so people can take a better respond, yeah, from our weather warning. So thank you very much. I hope, or if you have some questions, maybe we can enlarge our discussions into the end of the sessions. So I give feedback to Bu Alvita. Thank you.
Okay, thank you very much, Dr. Agi. Such an impressive presentation, so many example, and especially about the early warning system. And then we already have a few questions on the chat box. The first one is from Daniel Williams. It's about what role does the hydrology office have in the workflow?
Well, thank you. So Wait a minute, can I see the questions? Oh, okay. What the role of the hydrological office on our
Have in the workflow.
Okay,
Yes.
so in Indonesia, this is interesting questions because in every countries, this terminology is quite different, yeah. Because if we have a look on the global standard, it's called NMHS, yeah, National Meteorological Hydrological Agency. But in Indonesia, we have quite difference because we are only the National Meteorological Agency, and we have another agency. It's called the National Hydrological Agency. So we are on the really different organizations, but it's not just not matters because we connected to the really good collaborations and coordinations. Due to the time, I cannot give you an example. We have the really good collaborations on the flash flood guidance. Yeah, so we use the hydrological modeling that they provide. So when we use the flood modelings, that means we use the information from the hydrological agency. So we not run our own hydrological modeling. So we use the hydrological, there are hydrological modelings, but then we integrated it into our system. So then the warning will be delivered by BMKG. To be honest, the number of let's say the capacity to reach the people, it's bigger. I mean, BMKG, I think now is the biggest one to reach the people in Indonesia. You can also see the applications like Info BMKG, because we have like more than 6 million, yeah, to access the people, and including with the other strategy. But then for answering these questions, we use all those hydrological modeling for the flooding, for the flash flood, but then we will have the one integrated system, yeah, Bu Vita.
Yes, thank you, Dr. Agi, for your answer. Okay, and then the second question is from Jefe Permanente. The question is, how often do you update the demographic, population, and hazard information for your modeling?
Well, that's a good question. So
yes, it's a good question.
Yeah. Jeff, I think you clearly understand the basic concept of the impact-based forecast. So the first answer, I think that the area of the weather modeling, it will become or responsible by our agency in BMKG. But for the vulnerability and also the exposure area, of course, it's totally not our area that can manage on the yearly basis or the monthly basis. But glad we have another agency and another ministry that really work well on this area. Like the vulnerability, for example, our colleagues in the disaster manager, BNPB, they start to have more frequent update the vulnerability informations. From the 5 years basis, now it's coming to the yearly basis, but also there is so many supporting from the local government, the provincial basis. So they're providing much information about this, but also the other side for the demographic, that's meant for the exposure area. We also connected into the other agency or another ministry, which is they have the census and also the yearly information for this. So we quite use these informations. But again, sometime we need to also consider on the spatial basis, because the work for the geospatial is mostly sometimes quite difficult, because not all the area in Indonesia is already well assessed or well identified. But so far, we can get yes, at least the early informations, at least a good information for the basic one, so we can produce the impact forecast. But for sure, every day we start to strengthen the capability to give the good warning, the impact warning. I hope it's answered your questions.
Thank you for your answer, Dr. Agi. I hope it's enough for your question, Jeffrey. If you have any other comment, you can also write it on the chat box. And then the last question is from Karim Sabir. The question is, there are a few CARICOM using CAP. Not sure how widespread it has been adopted.
Okay.
Yeah, maybe you want to share. Maybe you have any comment for this.
Okay. Anyway, I'm not really clear actually.
About the cap.
Not the cap, but
Was just a comment.
the
Okay.
CARICOM. But then I can
okay.
answer the cap itself.
Okay.
Yeah. So anyway, the Common Alert Protocol actually is developed by the worldwide community. So this is the system or solutions, yeah, Karim. Yeah, this is I believe that you understand about this cap, but what I mean is the CARICOM. But so many developer, yeah, for this one. So right now there is a platform that still work by UN, represented by WMO, World Meteorological Agency. So we will release the new approach. It's called the Global Multi-Hazard Alert System. So it uses one of the solutions from the Common Alert Protocol because it's one of the really easy way, easy methodology to share our warning, because directly like the radio, media, like televisions, and now recently we can use the system by mobile apps, for example. So they can just integrate the information. So maybe later on, the question is how we can keep the quality of warning that containing from the cap itself. So when it's automatically delivered, so people didn't get the false information. So that's why WMO start to manage the alerting authorities need to be not just responsible, but also give some assess, yeah, to use cap for the weather warning operations. I hope it's adjust your comment, yeah, Karim, yeah. But it's happy that some of you is also common with the what it's called Common Alert Protocol or cap.
Yes, there are another two comments about this captain from Daniel Williams also say that Belize pursuing its implementation, work in progress. And from Mariette Francis, it says that the National Office of Disaster Service, along with the Met Office in Antigua and Barbuda, also use the Common Alerting Protocol tool for updates and warning.
Wow, that's impressive. It's really nice to hear some of you is quite useful using much, yeah, with the cap from Belize, Antigua, and Barbuda. So that's I'm really happy and supporting this kind of development. Don't hesitate to contact me because I also help the global approach that we still work. Yeah, I am part of the expert member that developing the GMS platform. So in the future, I always saying that this is a kind of the methodology, but also this kind of the shortcut or the easy standard that we can use. Not just only the purpose for the nations, but it's also for the international approach. But then maybe since now you are also developing and update this protocol, these tools, you need also to consider perhaps, yeah, from the conventional one for the weather warnings. Indonesia did some improvement with containing also the impact informations. So inside we also put the response authorities who can answer the alerting. Because if you study the structure of the Common Alert Protocol, actually it's so many informations inside, yeah. But sometimes some countries cannot filling all these informations because they're still not clear how or who can respond their informations. So it's good that Antigua and Barbuda you follow up this kind of approach. But I think if you can respond on the chat box also, it's already on the impact area or not. But if not, you can try what do I just share with all of you, yeah, in this opportunity.
Okay, thank you very much, Dr. Agi. It's a very insightful and informative presentation. I like the part when you talk about the shifting paradigm from what the weather will be to what the weather will do. It's a very impressive also because the early warning system is the thing that we have to develop every time with all the new technology that keep rapidly growing on our engineer life. So thank you very much once again, Dr. Agi. And I think we will start the next session with Dr. Army, but we still have 5 minutes until Dr. Army will start his presentation. So if you need some toilet break, maybe you can take this 5 minutes. Okay, so thank you one more time, Dr. Agi. Hopefully we can meet again soon.
Thank you. You're welcome, Bu Alvita, and enjoy everyone. I hope you have a really wonderful sessions and training.
Okay, but maybe we can have some photo first. If you don't mind, we can have this photo session. Please turn on your video for a minute. Okay, so do you mind?
I can see your face, yeah.
Yeah, so we can see each other's face.
Yeah, good.
Yeah, it's good. So some of the country tonight have some difficulty due to the internet, and we will share this record to the EduNext like usual. Okay, so we will have our picture for 1, 2, 3. Thank you. Thank you, Dr. Agi. Thank you, everyone.
Thank you.
We will be back on the
Thank you.
3 minutes.
Bye.
Thank you. Hello. Okay, we will start our next session. We already have Dr. Army here. First, I want to read about the short bio from Dr. Army. Good evening, Dr. Army in Indonesia. It's 10 p.m.
Good evening, Mbak Alvida.
Okay, so now we have Dr. Renat Army Susandi that will give the second presentation about implementation of multi-hazard early warning system and climate change information system. He will also show us the prototype of multi-hazard impact-based early warning system in SICA or CARICOM. So for the past 3 years, Dr. Army has served as the founder of PT Innovastek Glomatra Indonesia. And he also teach at ITB Faculty of Earth Science and Technology and the Indonesian State Intelligence College. So he is very busy and very important people. He specialized in the multi-hazard early warning system and the climate change information system. Dr. Army has a Bachelor of Science in Geophysics and Meteorology, a master degree in development studies, and a PhD in meteorology. He holds over 10 patents and copyrights. Okay, so if you're ready, without any further ado, the place is yours, Dr. Army.
Thank you, Ibu Alvida. So, buenos dias, good morning, ladies and gentlemen, from CARICOM SICA representatives, and good evening for the participant from Indonesia. Before we start, we have learned about the basic concept of DRR and another concept of climate change adaptation. In this session, we will talk further implementation of those concepts, particularly in the form of early warning system. Next one, here's an outline of our courses session, session. So in this section, we will learn about how the climate change and disaster affect your countries and how deep the impact, what kind of multiplier effect of climate change and disaster that will happen in the nodes if there is no mitigation anticipated, and how we'll implement the Sendai framework, especially of the MSIEWS part. Next one. In this slides, we expected climate risk-related impact in Caribbean and Central American countries. We have analyzed that as Caribbean island country affected by sea level rise increase, and of course, we can find hurricane occurrences. They will also isolated from supply and trade due to extreme weather affected by sea level lines. This condition could escalate into food problem and poverty as climate change also affect the main economic sectors such as tourism, fisheries, and agriculture. And of course, sometimes we can find also employment situation problem. Another side, weak Central American Peninsula countries still have the supply line. It also affected by the increasing severity, hydromedical disaster, such as for long droughts, severe heatwave, and other ones. Next, please. Disaster occurring in this slide, you can find left figure. You can see the increasing number of threat of Caribbean countries, especially related to hydromedical disaster. While the right one, you can see the central in Central American countries. Next, please. Then, how much the impact the climate change and disaster on daily life aspect? The impact of climate change and disaster could affect as far as material and moral laws. You can see moral laws including bureaucratic disturbance, lost family member, disruption learning process, and material laws such as damage on public facility, production of our upstream will be disturbed, disruption on land, sea, and air transportation. And later, and of course, the impact of climate change disaster, if there's no anticipated, could be widespread and they influence can threaten various aspects that are strategic sector. And of course, this condition could lead to social unrest, politically instability, and ratio for the economic growth. And of course, you can find that some country like Brazil, Mesir, Indonesia. Also, you can for example, in 1998, we have the changing of the government because of one of them, because the climate change. We find it such as forest fire, economic problem, and social unrest. Next, please. In Sender framework for disaster risk reduction, we learned that frameworks recognize the importance of multi-hazard early warning system in supporting the RRF4, especially priority for Action 2 and Action 3, particularly in commitment to invest in strengthening people-centered MHEWS. Thus, MHEWS become the center of climate change and disaster risk management for future direction. Next, please. And so now we are talking about multi-hazard impact-based early warning system. In these slides, after we learn the recent update of multi-hazard impact-based early warning system in global form, we will learn about how the climate risk and disaster risk management concept and how should it operate. And this MHIEWS concept and paradigm shift, the multi-hazard early warning system concept and paradigm shifting from risk-based decision-making to the risk-informed decision-making that lead to multi-hazard impact-based early warning system concept. How to boost, how to pressure the preparedness and respond to early warning system, we can see later in this next slide, please. Disaster risk management cycle, what side do you get it? And you see that so has critical truth into what created disaster and how the manifestation of the risk lead to indesirable outcome. And this process need more real-time accessibility, evidence-based and applicability disaster risk information, and make data publicity available and empower capacity building in order to lead the better value for the investment the country put in the research. So climate risk management, how do you get the recipe? In the rec one, you can see the climate risk management so that the climate change has several risks that could be anticipated or mitigated under such as comprehensive risk management in strategy. There are three major steps inside. One thing, analysis and assessment of climate risk management is based on comprehensive and continuous risk assessment. The second one, measure implemented for integrated climate risk management. Integrated climate risk management comprises a wide range of measures and instruments that can be combined wisely and effectively to suite of specific context. The last one is making and implementation decision-making maker from the public and private sector look at the integrated climate risk management measure, identify, and of course consider the related costs. From here, you could see how the CRM later affect the concept of early warning system. Next, please. Okay, and stay on page. What's your problem? Sorry, we have a loose. Oh, sorry, we have loose. Okay, we continue. Okay, Sorry, I think we had lost, but not. This slides multi-hazard early warning system concept. WMO or World Meteorological Organizations define MHEWS system cover a range of hazard and impact. They're designed to be used in multi-hazard contexts where hazardous events might occur simultaneously, cascadingly or cumulative over time, and taking into account the potential interrelated effect. The MHEWS concept developed based on risk-based decision making. But later, the decisions are typically made by technically expert without public consultation or stakeholder involvement. This model have been criticized by disaster risk practitioners because it avoids the cost of loss and damage. So it could not comprehensively touched by the other aspect. Next, please. And multi-hazard impact-based early warning system that we are talking about this tonight. The concept is evolved by shifting paradigm perception, especially how risk information could affected by aspect comprehensively. This impact-based itself has been developed by using risk information decision making as basis, using a variety of consideration of which risk data is about one factor, recognize and incorporate subjective reasoning, ensure that the technical aspect of the decision are balanced with human wants. This model has been used by disaster risk practitioners because it's including cost of loss and damage. So it could be comprehensively taught the other aspect. And how to boost disaster. Next one. How to boost disaster preparedness and response. Next slide, please. Yes. The MHIEWS also enhanced further EFRC by best action and forecast-based financing. These two concepts aim to prepare and mitigation action and how to respond to disaster warning by using forecast trigger. Next, please. And the next slides, you can see the climate disaster risk management concept in the era of 35.0. So we try to make friendly everything using machine learning and using computing. And this concept is human integrated social that's balancing economic advance with the solution of social problem by a system that highly integrated cyberspace and physical space. And of course, we try to put together and everything will be easily understood by the community and also by the people, by the government or other private sector using this system. Next, please. In this slides, after we learned on the concept of MHIEWS, we learned about how the lesson learned from the Indonesia MHIEWS implementation. The simulation of the MHIEWS concept is in CARICOM and SICA countries, engaging the stakeholder to participate in your countries and further challenge implementation of the MHIEWS. These slides, slide 15, lesson learned. This is our concept of Indonesia. The implementation of multi-hazard impact-based early warning system. Indonesia, following the concept above, Indonesia has a state-of-the-art multi-hazard impact-based early warning system. So we including the weather prediction, imagery data, special information, disaster information for many resources data. And after that, we find the data processing, development, disaster prediction algorithm. So important one, how to predict the disaster, for example, weather SM event and so on, and of course impact of the system. In this slide, slide 16, lesson learned for implementation of MHEVS. This multi-hazard impact-based element system has tried to including at least 4 major disasters. Once the hydromedical disaster that including flood, landslide, extreme weather, drought. The second one, seismology disaster such as earthquake and tsunami. And the third one, a volcano. The fourth one, forest fire. The system itself has tried to improve using Society 5.0 concept. So it could be one step ahead from Indonesian expert in assessing the disaster risk reduction. So the in this slide, the back one, please. Yeah. 16, Mastia. Yeah. We can also find the prediction of the disaster, that including prediction of the what kind of facility will be affected for disaster, and then how many people population will be affected of the disaster in the future. So after that, we can preparing for many risks, many activity to reduce the impact, to reduce the disaster in the for the future. So this is the advanced system that we have done for Indonesia. Next, please. So Indonesia UVS feature example, for example, hydromedical disaster prediction is, for example, that we have at least 4 major disasters. In this feature, you could see how the best forecast has been applied in Indonesia. We combine disaster risk in this indicates for each hazard with weather forecast for triggering the disaster potential. You could see that by overlapping the disaster risk index with other data, Indonesia multi-hazard impact-based element system could analyze easily the impact of its disaster potential. So this is very fun for the technology that we have done for developing for Indonesia. Next one, Indonesia multi-hazard element system feature example. This slide for hydromedical hazard disaster prediction. This feature could also help to concept implement to other type of disaster. For example, this slide you can see volcano eruption disaster. By overlapping the data, we could see the risk zone evacuation, and we could see for the implement of the financial mechanism for the loss. You can see from the figure, we can avoid the lava from the volcano eruption. Then we can see how to the staff of the disaster risk management agency to have the people in the same time avoid the disaster will be affect for the agency, the people. Next one, please. And this slide, yes. Now we try to quickly implementation of multi-hazard impact-based element system in your countries, region, CARICOM and SICA countries. This system you can visit from our website, fastic.com/CARICOM-SICA. This EWS prototype has developed from combined algorithm with impact-based forecast as concept with high precision and accuracy. This prototype expected as one of the solutions to strengthening CARICOM SICA disaster risk in understanding this outline course. Further, this prototype could be implemented in other impact sectors. And of course, for example, we can apply for agriculture and fishery sector also. Next, please. So let's see what we have done for the concept of MHIEWS for your countries. So this slide prototype development, the CARICOM MHIEWS prototype has been developed by using satellite imagery and other data. We try to collect what kind of data we can access, of course. In the future, you can provide by your country itself, and then we can manage together what you need, what you define for your activity in order to risk risk reduction for the future. Okay, Following the process, we could visualize the result of the potential disaster by using MHIEWS concept. Next, please. So, right now we have 4 or 5 feature for the CARICOM, SICA, MHIEWS feature. The first one, we have hydromedical disaster prediction. This based on impact-based forecast. The second one, we have a hotspot monitoring. And the third one, we have weather forecast. Fourth one, weather earthquake monitoring. And of course, we have potential impact of climate risk or agriculture. We can create for each country itself, actually, not only for the region, but also for one country, dependent of the data what you have or provided, or we can access from many other resource of data to develop the MSIEWS feature. This is the next one. We can explain for one by one of the feature. This feature, the first feature is hydromedical disaster prediction. By using this feature, you could see how the impact-based forecast has been applied. By using daily rainfall accumulation prediction, you could see which area that will have a lot of rainfall in a day as precursor to potential hazard. So actually, we can create by not only by region but also for each country, and the solution will be field resolution, as you have a data, of course. The next one, further its level as the separate action for financing. For example, the separate impact for flood, it has been stated that there's need for longer strain on emergency personnel and severe impact and utility. Using this impact metric, you could plan an immediate and appropriate response. So you can try to appropriate what kind of for example, the impact minimally. You can do something what activity will be planned for in the land. Next, please. The second feature is hotspot monitoring. In this feature, you could see the potential forest fire occurrences in the near real time. The hotspot has been categorized by confidence level, so you could easily determine if it was the fire occurrences or another fire sources. So for Indonesia countries or for other the some area will be a cure of the potential forest fire. Is very important using or develop this feature in order to avoid the more fire in this area, including US also. I think that US, for example, every June and July there are very many potential of fire occur in this area, including also in the Australia in just during December, January. They have also lecture forest fire in some area of Australia. So next one, the third feature is earthquake monitoring. In this feature, you could see there is an earthquake occurrences. Later, you could enhance this feature further with your unique early action for financing around the impact area. Later, you could integrate it with damage and loss assessment. So, what you need for you develop the feature, and we can create together. You can create by yourself using some machine learning or artificial intelligence. So next one, please. The fourth feature is weather forecast. This prototype is supported by weather forecast with high resolution up to 7 kilometer horizontal grids for hourly interval up to 10 days ahead. Weather forecast data including wind speed, temperature, humidity, and rainfall. This feature could also have your plan to immediately action needed for search and rescue. So, seeing seeing for the CARICOM countries or SICA countries, I think more accurate prediction compared to like Indonesia, because Indonesia they have a combination with land and sea. So let's see. I think that if you create the concept for the country, your country, CARICOM SICA country for MHIEWS, I think we can find to find the disaster and for the bigger one. So next one, the fifth feature is potential impact for climate in the agriculture. So the potential impact of the climate for agriculture sector, especially related for the planting time. We have applied for many regions of Indonesia to planting calendar. There, they get benefit from many reasons or many things. One thing that they can increase the production. They can avoid disaster because of heavy rain. They can avoid for many problems for the pest and so on. So they can manage for the planting calendar very accurately. We can guarantee for the planting calendar for 2 years later is really accurate. After that, we need for updating the data in order to make more accuracy for the next 2 years after 2 years from now. So I think we have I get the pattern for this prediction, for the long-term prediction for the agricultural nation. So we of course can learn from your country what kind of the uh, uh, forget something for planting from your country. For example, initial of them planting the paddies, and the second one we have also the planting the second crop for some specific area. Next one, the fifth. Okay, I think yeah, that's why we have a five feature for our CARICOM and SICA quantity for its implementation of the multi-hazard impact-based early warning system. So now, who respond for the disaster risk reduction, and especially for implementing of multi-hazard impact-based learning system? Of course, everyone. I mean, every stakeholder. In this, we need synergy. Of course, we need synergy. I mentioned above in Sunday framework priority. In action number 2, the Sunday framework call on government to move forward risk of involved governance arrangement that including a broader hazard and risk scope. So, and incorporate with sequence system, the current integrating across different sector and level of government, working with scientists, of course, civil society, and the private sector to address current emerging risks. So we combine everything, including the academician, government, private sector, and maybe also some from the media. The important one, pentaholic. This is, we can call this an integration of how the sector will be involved. Further, in the risk-informed decision-making, it requires extensive collaboration and ownership from many partners, including multiple agencies within the government. It's called for long-term and in-depth engagement to concept, national and local plan and legislation to real world impact. It also requires capacity development beyond the traditional training. Need to strengthen local institutions so that they are eventually able to coordinate it, solve problem, involve community, share information, and train others. And of course, therefore, borrowing pentaholic concept that we show you in this slide, the synergy between stakeholders also become a key success implementation of MHIEWS. So, for example, we can get the data from the agency and the expert from university, we can create the many algorithms, and of course, the people can get some idea to to give some input, and of course entrepreneur can use the system, and they can give also like credit for academician or people in order to improve the system, multi-hazard impact-based element system. And of course, government as a coordinator will be a key stakeholder also. So the next slide, the challenging, of course, this is very important one. The challenging of the implementation of comprehensive climate risk and multi-hazard element system, we have two challenging. We have social challenging and also technical challenging. The challenging of, you can see we have at least eight problem that you can see in the slide. The first four in upside, the challenging are fall into technical challenging. All of the rest challenging are related to the availability of the finance solution data. So data is very important one. The data is very solution. The good data is very key success for the our system. And then on the other side, the rest of four, you can see categorized as four challenges of the human resources capacity and threat of disaster. So saying we can try to solve the problem, challenging of technically and social also, so we can find the good condition for our system, multi-hazard impact-based our system. So, and then finally, we have 30 minutes running. In this last session, we will learn how to strategy to implement the MHIEWS and bureaucratic and technical one. And the summary is what we have learned. And the risk management strategy immediately priority. As you can see, there are four strategies that urgently need to be done immediately. The one thing is we need a mainstreaming action for prediction-based climate change, climate and disaster risk management, and anticipating forecast-based action, and also increase the involvement of stakeholder. So with this side, the left one is paper one is immediately prioritize risk management strategy, a bureaucratic side, and also from the involved stakeholder. And the next one, technical side. In technical side, there's an urgency for integrating the technology and system to enhance disaster risk management and capacity. Also, as you said, we need to further increase the understanding of the risk, preparedness, and early action plan through disaster risk government index. Next one, before we simulated the system. Next, please. So conclusion, we have three things: climate change, disaster, contain multiplier effect, and of course there will be influence for many things. And finally, from social to academic growth will be pressure under pressure for the climate change disaster. Second one, in line with Society 5.0 era, multi-hazard impact-based element system is one of the tools that can be used to streamline early action and preparedness in carrying out disaster response plan as a national alert. The third one, of course, we need synergy stakeholder with the pentahelix concept. We need the person, we need the people, we need the government, we need media, and we need also entrepreneur in order to support the concept of multi-hazard impact-based element system implementation in the country. And of course, as we say that before, we can apply for each country, not only for region, but also for the country that you are in region. And finally, say thank you very much. And before that, we can show you, Mastio will show the system directly from our website. Please, Mastio. Yeah. we can open the system directly from our website. Yes. Please, Mas Tio, explain the system. Ya, silakan, Mas. Ya, Mas Tio, saya jelasin. Silakan, Mas.
Okay, thank you for everyone. This is the system. You can see at the presentation later by Mr. Rais will share if you want to use the system. The account there will be share for you later. And first, here's the home system. We have specialists prepare for you the four features: hydrometeorology, weather forecast, forest fire, and earthquake. And for the first system, you could see that in this slide, these features here, the extreme weather, the hydromedical hazard. In this prototype, we use only for the extreme weather, because we need more data and more your regional data, like topography, like flood history, and etc. And we could support you with that. And here in the daily rainfall accumulation prediction, you could see that in some area of the SICA countries and CARICOM countries, there's some heavier accumulation, heavy rainfall. And here's actually it's Indonesian time, GMT +7. And if you go, we could change the date with more like 4 days ahead, 3 days ahead, sorry. And here's maybe there's the area of the Costa Rica, and maybe there will be extreme level 2 that doctor may have said before in the presentation. And also we have developed for you the possible impact that maybe will happen in the area. Actually, we have a first level of the area, like in Costa Rica is Punta Arenas and San Jose. And here's the possible impact that will happen for the level 2 warning. And maybe you could see the appropriate response, what you should do and what people should do in the area. And maybe each of these level has the specific possible impact and possible response to. And here's the resume of the area of the CARICOM and SICA countries that have possible the extreme weather at the 14th August in 2020. And here's is the hydromedical hazard. And as you see that we could have a more impaction that will be later we could develop in the next session maybe. And here's where you could see that there's a lot of things that you could explore in this application. And yeah, this time there's this level 3 or the last level, and what we say the metric impact in Honduras in the 6th August. And here's the area. You could see that in here that the area could be better, define a resolution, define a more specific area, targeted area. So you could see that because the lack of the data, we cannot give you best final resolution from us. But from the Indonesia experience, we could see until what kind of village that have impacted by the extreme weather or the flood or any other like flood, drought, and landslide. And okay, maybe I'm going to the next features. This is the forest fire. And here in the forest fire, okay, wait a moment. Okay, and here's the forest fire. You will see that in this part, you will see that there's some of the total hotspots in the CARICOM and SICA countries, and you will see there's the MODIS data, the MODIS sensor of hotspot, but you could change to the first, as you can see in the form used in from firms, forest, yeah, the NASA use. And here you can see that the result of the result of the each country hotspots. But the question is which area, which hotspot that the fire occurrence the fire occurrence happened in the area. And yeah, and like I said before, maybe in Indonesia experience, we could the MODIS data or the first data, not all of the data, the fire hotspot is the actual fire happened in the area. In Indonesia, we have found the case that the hotspot is related to the flare, the gas flare of the mining in the area. So maybe we can improve the hotspot better with the land use data, with the burn area data, or another data that you could make it sure that it was the forest fire or the another fire that maybe happened to be disaster in your area. And the fourth.
Wait, please. Wait,
Yeah.
Mastio. For Indonesia, for the hotspot forest fire prediction, we are lucky. We are the completely data. For example, we are also data for the owner of the land. We also data what type of the land, what type of the vegetation. So we can combine everything. Then, if we find the hotspot, and we can make sure this potential of the forest fire. So we also social data. So the completely data is for Photon want to make sure that the forest fire prediction is very accurately. So of course we can develop the data for the country, and of course we can access the data in order to develop the CARICOM SICA region as implementation of MSIWS concept. So as Mastio said it, we of course we have still lack of data from your country, and of course we can ask someone, maybe your country they have the data also. For example, Indonesia as a
National
Belize country, we have lucky for national data. The data also distribute for the center from our national disaster agency. Then we can use data directly for from the access from our campus. Please, Bastio, continue.
Okay, thank you, Dr. Amir, for the additional information. And here, the next feature, we have the weather forecast. And yeah, we try to develop our weather forecast for the CARICOM SICA region. And we see that there's a lot of as you say, yesterday, the third session that Dr. Rice has show you that about how the historical tropical cyclone, and here is the wind speed on the area around the Caribbean Sea. And you say that, yeah, we know that there's a lot of historical tropical cyclone over the Caribbean Sea and impacted also the Central American Peninsula. So it could affect all of the national all of the regional disaster. And here you can see the tsunami weather forecast, the rainfall, and the temperature for each day. And here is the result for prediction for 7 days ahead. Yeah, you could see. You could also you could also search for the area here, like the Honduras condition in Honduras in GMT +7 for the data now. And here's you could change for each for 3 hours. That's for the extreme for the weather forecast. Maybe Dr. Ami will have any additional.
Yes. For our country, Indonesia, we can also predict the for the weather forecast. How large impact for the weather? I mean, how impact for the infrastructure building, public infrastructure, and so on. The next one, also we can calculate how impact the area for the people for population. How large number of population will affected for the weather extreme event in this our website. So we can create we can adopt for many data for more data analysis. So I believe it. We have believe it. You can't also the data. For data for you just ask somebody for your country the data that you need to overlay that you need for analysis. For example, like Indonesia also. I think we can arrange for many project for preparing the data for your country, or maybe some additional supporting for international institution. So that's why. So in this case, we are only need for select how to develop the machine learning and artificial intelligence to make everything to support our analysis for disaster in this area. And of course, finally we can find for the activity and info to avoid the disaster. Please, Mastio, for the next one.
Okay, and the last features, the earthquake monitoring. And here you see that we could improve it better, so you can use it easily for your information to the people of your citizen in the region. So here in the last, we use the USGS data from the United States Geological Survey data, that the last 24 hours and to the last 7 days, and each like you see that in the last 7 days, maybe I will give you as an example. And here, okay, maybe last month for this mobile, lot of better, much more data. Here is like some in Honduras. There's a earthquake, 5.0 Richter scale with the depth around 10, and the location, and etc. Here you can just because the limited data available from our side, we only see that only the point out the location, but actually in Indonesia place, you could see that how far the zoning impact of the location, and how far the MMI scale, and how deep the impact. We could see in Indonesia, we have globally integrated Indonesia, and we already have the what we say. And maybe if there's the earthquake happen in the sea, there will be potential tsunami or not, and etc. And also it will be any kind of the dollar assessment or the damage and loss assessment, etc. And that's all for me, I think. From I see. Just forgot that each of these color is have the magnitude. If the color is yellow, you can see that this will be 5 to 6 Richter scale. I think that's all for me, Dr. Armi Susandi, and
Yeah.
give back to you.
Yeah, for this feature, you can see that we can develop the such as vulnerability map of disaster from earthquakes. From those, we can prepare for infrastructure strategy, that including also how to manage the people population to communication to avoid the area of the area will be vulnerable as an earthquake. So I think we can come up with the many objective from this map, because the map is a digital map. So yeah, that's why I think easily to use one thing the data, and on the other thing we can use what kind of the objective what we need from this your country in order to avoid the disaster. So I think that's why we have in fast and the short time to develop the CARICOM SICA website for implementation of the multi-hazard impact-based elimination system that we have done for the short term. And I think based on the data we can create later for the more data, more analysis, more useful, and of course depending on the one thing for the data, depending of what do you need. And after that, of course, we can create together and in cooperation with your countries, CARICAS SICA region for many result of the activity. So I think that Bu Alvita, I think we have done for our presentation, and I think we have a proof for the participant that we have create not only the theoretically but also implementation that we can propose for our government in CARICAS and SICA region. Thanks a lot. Thanks, Matteo. And of course, we come back for to Ibu Alvita. Thank you all. Thanks a lot.
Okay, thank you very much, Dr. Army, also Mastio, for helping Dr. Army. It's a very interesting presentation and a very amazing program that you give to us and show to the participant. And maybe, as Dr. Army already said, all of you already see the system that Dr. Army already built on a very short term. So maybe some of these participants can give some comment about the system. I think it will be very nice if we have some discussion about this. Is there any, maybe? Maybe some check and recheck or validation from people that really already live in the area, and maybe some of you already tried the system. Dr. Rais already shared the on the chat room how the user and password can be used on the system. Is there anyone already tried, or maybe some of you have some difficulties? Because the Rashid Al-Kwijai said that I tried, but for some reason I couldn't get in. Is there any one of you that have been tried and already success to go to the system? Because I tried and I success. Yeah, Karim Sabir is saying yes. Okay, is there some comment, Karim, for the system? Maybe in a glance, you already tried it, perhaps?
Yes, I think of course, yes, you're able to access the platform. So I think you have also some command for the system that including we can start from what you needed, what you want to do, analysis for disaster risk reduction. This is important one because the tech the expert like from Nisha, they can translate what do you need for some effort to avoid the disaster in your country. So this is the idea, and of course Masti also will happy to get some comments, some review. Yeah, Masti, yeah? Okay, Masti for our system. And of course, this is very simple one that if compared for from Indonesian system, it's very complicated system because we have a lot of data. For example, as I said before, we can know exactly what the disaster like heavy rain will be affected for the some village in the region, and also how many people will be affected, how many infrastructure like education infrastructure or another will be affected in exactly in the future. So we have approved it for the disaster analysis prediction in Indonesia. So that's why I think yeah, we try to simulate it in the short time for try to develop the implementation of the MSIWS for CARICOM and SICA country.
Yes, it's very impressive for the very short time you already built the system. Karim Sabir raised his hand. Maybe do you want to say something, Karim?
Yeah.
Please.
Yeah, I think they have some question from the Anna Tucker Abraham.
Yes, there
Please
are
describe
some
the role
questions.
of the
Yeah.
student to manage. Yeah, we can use the student. We can open the system actually
Yeah,
for this.
sorry, I was speaking just now. I'm not sure if you could hear me.
Yes.
Yes. Yeah. I'm not hearing you. Maybe you can. Try to
Describe him.
say it again, Karim. I'm sorry.
Okay.
Because yeah, please.
Are you hearing me now?
Yes, we can hear
you.
you now. Please.
Okay,
Karim.
thank you. I was just thanking Dr. Army for the presentation and for preparing the portal, because this is quite this will be quite useful for CARICOM member states. I was mentioning the Caribbean Institute of Meteorology and Hydrology, who have co-developed early warning systems across timescales. It's called the UESATS consortium, where there is sectoral co-development of forecasting products. So Dr. Army had mentioned the agriculture forecast to assist farmers in planning their planting and their crops, etc. We have a similar program for that, and we also have one for tourism, where we do a forecast for SPA, and we do a forecast for hot days to do heat wave forecast for tourists. One of the challenges, however, and I know this is just a prototype, and it is using global data sets. One of the challenges, however, is the accuracy for a number of the smaller islands, where one of those pixels is literally the size of the island. So there is a need for a lot of downscaling and validation of the models. So the Caribbean Institute of Meteorology and Hydrology has been busy trying to downscale and do their own models based on global data sets. And I think they're also developing an impact-based forecasting platform as well. So it would be very interesting after this training to continue the discussions with some of the stakeholders within CARICOM to see how we can synergize and utilize the products. Thank you.
Okay, I think
Thank you. Yeah.
yes. Karim is, as I believe that you are really understand what the uh, important one for the system information system for weather prediction that impact for the many field, including tourism and so on. So I think the good idea also what Pak Karim said that they can develop furthermore for impact based because of sometimes the stakeholder and also government uh, really feeling that the more benefit if we are calculated impact not only for the generally but also for impact based including economic scale or economic laws and so on. So I think we can cooperate later because I understand you have good experiences for many application of the weather prediction and its impact for many field. I think as an appreciate for your activity, for your background and so on.
Okay, thank you. Mr. Karim is from CARICOM Secretary. So, CARICOM from CARICOM Secretariat. So, thank you, Mr. Karim. And then there's the question. Please describe the role of the residents in managing and monitoring early warning system installed in their communities and how their involvement is integrated into the national system. Please, Dr. Army. Dr. Army?
Yes, please.
Yes, this is the question. I think you can see it on the chat room and also on the screen. Yeah. Please describe the role of the
Yes.
resident. Yeah. Please.
Yeah, as we have some experience that we try to include in participation of the resident. Then there we develop uh, the in the mobile phone that application then they can use directly and that in the simple one of course compared to the web based then they can also participate in with the as verification of the situation in the field. For example, we predict for this area will be in fact for the heavy rain that they can participate for say that area is impact affected by heavy rain and so on. And this is the second one. They can use for many objective of the application for many activity. For example, um, uh, yeah. For example, they use for some party and then this for the next 10 days they can use exactly the area is still is avoid from the heavy rain and so on. So and we have used some model and some for the for the resident. And for example, the last one we have applied for East Nusa Tenggara in one region in Indonesia, East Indonesia. They use from for preparation of the planting calendar. They know exactly when they're starting for the planting calendar. For example, normally the planting calendar, for example, say in October, but based on our system, they can starting in September because we have rain. starting from September for the 3 months later. So I think the participant can, and after that we can get some input from the farmer for the accuracy, and then of course if the accuracy will be lower, we can improve our system again with the new data for the recalculation, something like that, Bu Vita.
Okay, thank you very much, Dr. Army. So is there any other question? Maybe we can have another slot question. If it's not, so Dr. Army, thank you very much. You already show us the very interesting presentation and system that you built. You show us about the pentahelix nexus from all the stakeholders that will build up the better system. You show us the concept and demonstration of the early warning system for extreme weather and multi-hazard, and the climate change information system that incorporates relevant climate change impact and adaptation strategy. It's very fruitful meetings. So thank you very much to Dr. Army, also to Mas Tio that already help us and show us the system, this session. So if there is no other question, maybe I will close this session. So see you again tomorrow. Tomorrow we will have Dr. Rais that will give the hands-on activities about the mapping impact chain of particular hazard, and also we will have some final tests tomorrow. So maybe you like to read again all that we've been through this week. Okay, so once again, thank you very much, Dr. Army and Mas Tio.
You're welcome, most welcome.
Yes, see you again tomorrow.
Thank you, Mas Tio.
And bye-bye.
See you.
Bye. See you.
Thank you. Bye.
Good night. Good night.
Thank you. Good night. Bye-bye.
Yeah.
Bye-bye.
Have a good day and have a nice sleep for Dr. Army. Thank you.
Gracias.